lecture, I'm gonna start automotive electronic, and I'm gonna start with wiring system. So I'm gonna share my screen and share how to calculate the proper gauge for the proper wire. Because as I said, if you do not have the proper gauge, definitely you are gonna have some trouble and you won't be able to send the right power to the system. So let's start from the purpose. Definitely we need, in order to have like the wiring, the right wiring, we need to have a good understanding of the gauge of the wire. And of course, another purpose in here is, in addition to that, circuit protection. Circuit protection is more focused on having some contactor or fuse, right? In order to make sure if I'm having overload or if I'm having over voltage, the circuit by itself is able to disconnect and not to damage the component inside the circuit. So that's why we have to have a good understanding of that part as well. So let's start with automotive wiring. How many of you are familiar with which kind of wire we have inside the automotive? Pardon? Which side? Well, in fact, we have to say we have two types of wire. Some of them are solid, or we call them standard, right? So some of them are solid copper. Some of them are a strand of copper. Simply means if I have like multiple wires being twisted or being protected inside one isolator, something like this, which most of the time is PVC, we call them a stranded copper conductor. Means it's not a single wire, right? Instead of having just one thick wire in order to pass the voltage, they divide it to multiple wire, and then they cover it or they protect it through such a insulation. This is what we usually use for insulation, right? And then they are able to send more power through such a strand of copper covered by plastic insulation, which is PVC. But when we have only a single solid wire, definitely we have to consider, since they are not under the same connection, we have to consider the thickness of that one. So this is not a single wire anymore. The thickness is important. That's why we say we have two types of wire. One of them is solid copper, which is conductor. These are the solid copper. These are conductor. These are going to pass the voltage. And we have like multiple copper, which mostly it is used for electronic inside the automotive. So this is what we call it in automotive industry, wire harness. And in there we have like engineers to be assigned to only focus on wire harness design. I myself was the leader of when I was engineering design. That was my first engineering position. Working as an engineering design or engineer design, something like that was the label years ago, almost 20 years ago, inside automotive industry. That was my first position. I was assigned to only focus on wire harness design because this is really complicated and by itself is an engineering skill. We may think only the size of the wire is the like, let's say, the topic of the focus, but even how you twist them, how you apply like insulation, even the type of the connector, which type of the connector you want in order to make sure you have a stable connections between the wire and the component, even the extra insulation on how to wrap the wires to avoid noise inside the vehicle, because this is what it goes to the ceiling. Therefore, if you do not have a right design for such a wiring harness, while you are driving, after some time, there are clips, right, which going to connect these wires to the ceiling. And some of them, they are going to the floor. They are clips. If they do not have a good quality or they do not have a stable connection, after some time, they are broken. And then the wire is loose. And when you are hitting a bump or you are in higher speed, they will create horrible noise inside the vehicle, which is considered maybe low quality design. Therefore, for every single one of them, we used to go through prototyping, we used to go through lots of testing, driving at highest speed, putting the vehicle after installation, the wire harness, putting the vehicle on the vibration board and apply like super high vibration to the vehicle to kind of demo in the situation that we are driving in a road which is not as smooth, to make sure in any of those situations this is not going to create noise. And of course the durability was super important because we don't want to lose the connector and we do not want to lose the pin or the clips which is connecting this to the body or chassis in case it is directly connected to the chassis. More specifically above the driver, above the head of the driver, because if it is creating noise, it becomes really annoying for the driver while driving. Therefore, this is super important. It's not only about the wire gauge. The entire process by itself has like a very strong team of experts inside the automotive industry focus only on wire harness. And it's not only focused on electrical design. It has another focus on, I would say, CAD design. Back then, we were using AutoCAD plus CATIA. In that company, CATIA was very like normal. CATIA, I'm not sure how many of you are familiar with CATIA. A lot of you. So maybe in most of the companies right now, they don't use CATIA because CATIA has two versions, Unix or Windows. So the Windows version is much easier, but there is another type of CATIA which needs a different computer, which is used only for that certain like design. It's not used for any other application, right? So CATIA under Unix. So CATIA, back then we were using even CATIA. Still AutoCAD was there. We were using AutoCAD for simpler design because that version of CATIA is a very, I would say, high capability version. It is very expensive. That's why it's not common in everywhere. But when you are dealing with such design with lots of detail, lots of components, tiny component that needs to be accurately designed, it's better to have a great software that can communicate between both hardware and software. So therefore, this is a complex process under automotive design. Now let's look at this one. I just said we have a standard. I would bring it to your attention in here. American standard and European standard are not the same standard. It's not only about the name. They do have some minor difference. Well, for example, about not only, as I said, not only color, even about how to do the wiring, the process of wiring. Do I want to first go from this part of the system or first go from that part of the system? They do have difference. Since we are in North America, we are just focusing on American standard for wire gauge. So wire gauge may be differently defined if you are from any European country or you are going to work in European country. You must look for the European wire gauge or wiring standard. Therefore, in here, we are going to start from gauge, higher gauge to lower gauge. You may think if I'm having a higher gauge wire, simply means that wire is stronger, but it's the other way around. Higher gauge means smaller, or I would say thinner wire, which is usually like, for example, jumper wires or any wire that we are using, for example, for the radio speaker connection, which is jumper wire. Therefore, lower gauge, in here you can see lower gauge is for high voltage like application, and higher gauge is for low voltage application. If I'm having the thickness of the wire to be less, then the gauge is high. These two, they do have opposite relationship. So I would say if the AWG is high, then I'm having lower thickness. Make sense? Another way around, if I have AWG to be smaller, then simply means the thickness, this is thickness of that wire is greater. Make sense now? So suppose I'm a battery designer And I'm supposed to send, usually for the battery, the cable that we use is gauge 4. It's thick, it's really thick, and therefore it's not as flexible as possible because it's thick. For battery design, we use gauge 4. For anything like radio speaker or maybe low voltage application inside the vehicle, we use something between 20 to 22. In here, I'm having the dimension of each of those wires. So we start here. It is a start from the like maybe greater AWG to smaller. Here you can see, for example, if I'm looking for gauge 4, which is the one which we use for battery system, look at the diameter in millimeter is something around 5, right? Around 5 millimeter, right? And if I'm using, for example, 22 as a radio speaker wire connection, 22, it's gonna, anything after here is the same gauge. That's why in here I say 20 to 22. This is going to be at around 0.8. See how thick this one, how thin this one is, and how thick this one is. So do not go wrong if I say 20 to 22. All of them, they do have the same thickness, but they call it 20 to 22 AWJ, and the thickness is AWJ, and the thickness is around 0.8. Not exact 0.8. Very close. Make sense? Now, you're supposed to go ahead and pick the right one for different application, which I'm going to give you a general equation to do so. That general equation is useful, but before I move to the next step, I'm going to say in order to calculate the right gauge, or I would say how to calculate the right diameter of the wire, in case you do not have this diameter, and in case you are the engineer who's supposed to design what gauge I need to pick, simply you do not go ahead and calculate the gauge. You calculate the diameter of the wire, and based on the diameter of the wire, you come to this standard, and then you pick the gauge from the market which has the closest diameter to the one that you need in order to power up your system. Make sense? So now let's look at that. How do I do it? I would say DAWJ, and this is just a standard equation. The constant 8.251. You can use this even for your final project, not in this course, for your capstone project, times, keep it in mind or take your note, minus, but definitely you can find this on internet, minus 0.1 approximately, but I'll give you the exact number, 0.1159. And then this is going to be AWJ, and then it's gonna give you this exact thing. You have to include the AWJ in here. This is gonna be in the unit right in here, millimeter. Definitely you can have the conversion to inch if the inch conversion makes more sense. So in order to make it more understandable for you, I'm gonna give you one example quickly. Suppose I'm gonna look at the diameter of 10 AWG. If I don't know what is the 10 AW, this is the 10. I'm gonna just give it a chance to see if I can find this one. I have the table, but in case I do not have the table, if I'm gonna calculate the diameter of the 10 AWG, I simply need to put 10 right in here. Therefore, I have to say D for 10 means diameter for 10 supposed to be 8.251 times e to the power of minus 1159 times 10. And if I calculate for this one, diameter is 2.500, I round it, 589. That's why I'm gonna say approximately. 5, and then the units millimeter. Make sense? Now the diameter for gauge 10 is almost 2.6 millimeter. Make sense? That's how you calculate. So Let me look at this wire gauge. This is another table right in here. For automotive application, as I said, we have a standard voltage and wattage based on what component we are going to connect. Therefore, the length is also important. Length always has a direct impact on the voltage loss because wire acts like resistance, right? Or resistor causing resistance, causing voltage loss through heat. Make sense? Therefore, if I'm having a longer, or I would say lengthy wire in the system, I may lose some voltage through the wire. Therefore, it is super important to look at the length of the wire. So, length is the distance of the wire from the battery. So this is the distance from battery, or I would say voltage source. So it is important to have it as short as possible, right? So now, what is the equation for watt? Everyone knows it, but quickly. What's the equation for watt? What? W is I V, right? What is V then? IR. Then you can say what is I to the power of 2R as well. Make sense? If this is IR, then you can also see V, you can say VI2. Make sense? So keep this basic information. So here, everything that you have right in here, right? For example, 6 volts at 12 volts at 6 volts. These are the amp, right? These are the amp at 6 volt. Means these are the current at 6 volt or at 12 volt, right? Therefore, this information are in amp or ampere. Makes sense? So let's look at the wire. Remember I said wire length. If this is my wire, it has a length. And if this is the battery, I call it B. The length or the distance of this from the battery to any component. This is super important. It has a direct impact. So if you have wire right in here, then I'm going to calculate resistance. Resistance is resistivity. This is resistance, is resistivity. We show it with rho. And then what is the impact of this length? We just put it down right in here over what? A, which is area. So A is area. I leave notes. This one is resistance. This one is resistance, and this one is resistivity. Let me show it with different color. Resistivity, resistance, resistivity. This one is area, and this one is length. Everyone got the point? So for a small gauge, area is bigger. A small gauge, area is bigger. Remember, we just calculated in here. If I'm having a small gauge, for example, gauge 1, my area is bigger because my diameter of the wire is larger. For higher gauge, my area becomes smaller naturally and based on the table. Makes sense, kids? Everyone? That's how you understand it. So let's look at one example. For example, if I'm having 5 amp right in here, which is highlighted, what's happening in here? This is in unit ampere, right? If I have 5 ampere, it simply means at 6 volts, we have 5 ampere. This one means at 6 volts, we have 5 ampere, right? And 30 watts. And this is the watt. 30 watts. 5 ampere and 30 watts or 30 watts. You calculate it. If you have 5, you put the 5 here, and then 5 by 6, you calculate it. Let me do it. Means if you have 5, and then it's at 6, means you have 30 watts. Make sense for everyone? Good. So, wiring is very important. Again, because if we do not have proper wiring, we may have heat generation, and through heat generation, we are going to lose some of the voltage. If we are planning to have 6 volts and we are having a wrong wiring, wrong length of wiring, we may lose some of this 6 volts. Therefore, if the components we are going to power up has a minimum of 6 volts in order to power up, if we have less than 6 volts, we are not able to power it up. Make sense why this length is important? So, if you have such a standard, I left you one example in here also, except the one that I mentioned. So you have to look at the length and better to make sure that it is more than 15. And in this example, for example, in here, so this one, you can see if you want it for 10, it has to be 18. You are going to have similar problem. I'll be solving more problems for you next session. What would be the right length for the wire if, for example, you have 6 volts and you have 5 amp, and then you have to do your calculation and then come here, look at the table, and based on the table, for example, say I have to pick the 8 or 18 feet for that application, or if still I have 6 at 6 volt 5 amp or something, or I have to pick 16. That's how you, and I'm gonna design a trailer, and I'll get you to, for example, wire the back of the trailer. Suppose you are going to connect a trailer to your regular vehicle, or if you have a truck, to your truck, in order to transfer some, I don't know, furniture or whatever which is large and it doesn't fit inside your car. Even if you are not an engineer, still you need to be able to do some safety features, such as having maybe some light on the back of the trailer to signal for the other drivers when you are turning to left or right, because the trailer is covering the back of your actual car. Therefore, they have no idea if you are signaling, if the actual built-in lights are already covered with the trailer. Therefore, I'll teach you how to design such manual signal for the trailer easily, right? Next time. So, any questions so far? In addition to hot wire, or I would say, in addition to the one which is going to be used in order to transfer the voltage, we have to always consider ground wire in any electrical system, right? Although many people may think ground wire is supposed to do nothing for me, but if you remove the ground from the system, it will work. It will completely stop working. Ground in automotive is between the engine and the body or the chassis, right? So you have to have one ground wire to be connected to the body in order to make sure that you have your negative terminal of the battery grounded. That's super important. Most of the time, the ground wire is just insulated copper, right? You connect it to the body, and that's how you connect your ground in order to discharge without the risk of electrical shock or without the risk of fire inside the automotive. We use ground between, as I said, the engine and body and negative terminal. If this is very close to the battery, so it has to be engine, body, and negative of the battery. These are what we need to ground them. There are 2 types of ground wire. Either they are isolated, right? Either they are isolated or isolated copper, or they are braided ground strap, means they don't have like insulation. Either of them will work. They are made from multiple wire together, very similar to what I show you right in here. Multiple wire together are connected. Either will be used for the grounding. So next is about the skin effect. How many of you have heard about eddy current before? Is the current flow along the outer edge of the system, which we call it, if you have a current to flow, if this is the outer edge, or this is the outer edge, if you have current to flow through the outer edge, that's what we call it, eddy current. If I have the current right in here, this is supposed to cancel out the current at the center wire, right? So simply means, we call it also a skin effect. This is what we call it, a skin effect. Simply means your outer edge current, which is like outer edge current here and here, or the skin effect of, if this is a piece of wire or conductor, you can call it, this is a piece of wire or conductor. Then if the conductor is either an even conduction inside the wire, then we are going to have some skin effect. So in this picture, you can see that how it will change. So for example, I'm having some, this is the, let's say the current in here edge, and then the skin effect is against it. So then a skin effect or eddy current starts in the center of here. This is the eddy current in the center, right? So this is something that we can calculate it. This is considered as the size of the circle. Based on the size of the circle in here, you can calculate. So what is the size of this? Then you can calculate the eddy current. We don't need it for this course, but it is something that it is easily you are easily able to calculate it. Next is about, remember I said it's not only about the gauge of the wire, it's about even protection of the wire. Protection, many of us may think only is just the insulation around the wire, but in addition to that wire protection, we need some external components such as fuses, which may have different type, or what, except fuse? What other protection we have? Except fuse, we have breakers. What else? So breaker or circuit breaker. Fuse or circuit breaker, which we are going to discuss it as much as the time is allowed. Fuse is always something we have to include it before the device, right? Why before the device? Means between the device and the source. Simply because if for any reason source is sending more voltage and fuse has a direct relationship with the wire gauge. Therefore, not every fuse is the best choice for every wire, because some wire, they are able to pass more voltage. But if I apply maybe a weaker fuse before that one, and then the source is sending too much of wire, fuse can blow easily. You are going to lose the fuse. Therefore, fuse also, like wire, has some table, has some standard. We have to pick the right size of the fuse for the right purpose. So we recommend always to look at the proper size based on the even either color. If you are very experienced, even looking at the color, you can say this fuse can handle how much of, let's say, current, right? If not, always look at the data sheet, and based on the data sheet, find out what would be the appropriate fuse for your application. For example, here, these are the blade fuses. In addition to the size, the type is also important. Not every type is a good choice for every application. These are the blade fuses, and they come with different color. For example, this one, green. Let's look at the table. If I look at the table, which one is the green one? Dark green. This is going to be rate 1, right? Or let's look at the yellow one. Yellow one should be something as strong, which it is right in here. It can handle up to 20 amp. So in here, opposite to the wire gauge, the numbers are matched. Means if you have a bigger, like if you have a bigger size, simply means it can handle more voltage, right? So this one, it can handle up to 20, but for example, this one or this pink one or the purple one, this is the pink one or the purple one, they are able to handle less current, right? So that's another thing that you need to understand. Well, there are another type of fuse, which is like mini fuse. We usually use them for troubleshooting, or we usually use them if we have already a fuse and we want to make sure that the system is secure enough. So we add a mini fuse. We call them fusible link. Therefore, these are not actual fuse. These are link. It's like something to boost the performance of the fuse to make sure the circuit is accurate enough and it can disconnect, and the fuse can disconnect the power from the system as fast as possible. That's why we call it, excuse me. That's why we call it mini fuse, and we can replace them with fusible link. Again, for the rate of the fuse, we have to look at the circuit, and then we have to look at, when I say the circuit, means the wire. We already find out for that device what is the wire gauge, and then we have to come here based on the wire gauge. Wire gauge is talking about the tolerance of the voltage and current, and therefore we know right now what is the voltage and current. So we can come here. This line is again current in unit amp. Therefore, we can go ahead and pick the right fuse accordingly. This is how we choose the right fuse for our application. Now let's look at another type of the protection. This is what we call it cycling circuit breaker. Breaker also, it might come with different format, different type. As the name is introducing, it's a breaker, very similar to fuse. It's supposed to disconnect the direction or the path of voltage from the source to the system. So, but the thing is, application of this type of breaker is interesting. So look at here. This one has like a strip. This is somehow metal, but it's a very soft, flexible metal. In case that you are applying more than the proper voltage or the current to the system, this will reshape or break or disconnect, right? Because it cannot handle just every amount of current. That's why we call it cycling circuit breaker. So it will react whenever I have excessive current, and then it will disconnect, it will break, and accordingly, I'm gonna save my system. Generally, this is the structure of circuit breaker. Circuit breaker may act like a switch. Means it has two states, on and off, right? It's not like fuse. Fuse, we cannot control it. Circuit breaker has a switching circuit inside it. That's why we say it will change the status in order to like react whenever we have excessive current flow in the circuit. So again, why we use it? Because we are going to avoid applying too much of power to the system. Here you can see another protection. We call it PTC circuit protector. This one has multiple status. This is looking at the temperature. Therefore, if we have high power, very similar to the heat generation inside the wire. If we have high power inside the wire, wire will heat up. This one acts more like a temperature sensor. It's not a sensor, it's a breaker or it's a protector. Anytime that we have high power and the system is hot, then this one will react in order to protect the system, which is called PTC, standing for positive temperature coefficient. So initially it's in solid state, but if I'm having heat being generated through like too much of current, what will happen? It will change the status and it will act like it's been heated, it's getting melted. That's why we call it positive temperature coefficient. So this one is against like fuse or circuit breaker. So it won't open the circuit. Still it is there, but it won't pass the voltage. So that's why I said voltage still it is available to the component, but it will minimize the amount of the voltage. So it won't, for example, if this is the PTC, it won't disconnect and become something like this. Still the connection is there, but as soon as it is detecting a little bit of heat, it will minimize the voltage. Means through the heat generation, it will get rid of the excess heat. And it will send less voltage to the component. Make sense? So it's not a breaker, it's not a fuse. It will somehow control the power being sent, and it will convert it to a lower current to make sure that the system or the component are still in a safe condition. Makes sense, everyone? These are important, especially for your second midterm exam. It's super important to understand the difference between these protection devices, how they work, and why we use them, and how they can help the system to still stay safe. That's why I try my best to simplify the definition of each of them and the application of each of them, right? So another one is fusible link. Fusible link, it doesn't have anything in terms of the look similar to fuse, not anything similar to breaker. It's just more like a wire, but it has its own format. So this one is acting like, so I have one of them in here. Look at here. This is the fusible link. Do not get it wrong. This is another, like, so this is the battery cable. Remember I said battery cables should be at around gauge 4 because it is very thick. This is the battery cable. See how thick it is? Around 5 millimeter or so. And then the battery cable, if this is black, simply means this is the ground, right? If it is red, simply means that's the positive connected to the battery. So now we connect the fusible link. You can see right in here, I have one and I have one to terminal of the battery. Terminal means positive and negative. We directly connect the fusible link to the source. And I always, I said, always we look at the length of the wire from the source, which is the battery, to the component. Fusible link is something that we directly connect it to the terminal of the battery. And then if I'm having over voltage, there is like a layer inside it, which is turning, which is kind of, it's damaged, it's torn right in here. So, and that's how it can disconnect. When it is torn, it can, when it is disconnected, it simply means it's not going to let the power to travel from here to any component. No current when it is torn, when damaged. And that's how it can protect. So any other fuse or something can be connected to the actual component, but if we have fusible link, it has to be connected to the terminal of the battery, and it is super important that you pick the right gauge. Pick the right gauge of this one, because this one also has different gauges for different applications. So I'm going to introduce one more, which is the mega fuse. Mega fuse is something that most of the advanced vehicles, newer, brand new vehicles, brand new companies, not brand new company means nowadays than the like older vehicles from 20 years ago or 25 years ago or so, because mega fuse is easier to use and safer to use than any other devices for protection. So recently, automotive industry is more interested in using mega fuse in order to protect the circuit. Therefore, this is easy. They simply can connect it to, as you can see in here, they can connect it to the tabs. If this is the tab, they can simply put it in here and then put like add some bolts and then secure it easily. That's why they use this one more than everything else. So for example, it is going to protect the battery. It is going to protect any component which is directly connected to the battery. And of course, if you look at the range of this one is 80 to 250 amp. So it's really good for high voltage application. Another type is, this is just quickly like different wires for the conduit, electrical conduit. Everybody at least one time saw this like conduit, but most of the time we have like the black one, which is like used in maybe any educational laboratory, but in automotive industry, they mean something different. Therefore, also you may find different size of the same color, but it is super important to consider because it's like wiring standard. Color means something. For example, you have multiple wire and you wanted to cover them in order to create a protection around them to make sure they are not loose, moving around, or maybe they are not touching other components like in the front or anywhere else. Therefore, you have to just cover them with some conduit. So black is designed for high temperature. Any part of the vehicle, like for example here, or maybe here, look at here, you have black one. Anyone closer to the engine is more exposed to heat. Therefore, closer to the engine, you can see blacks more than everywhere else, right? Because this one is stronger to tolerate temperature. If you see the black is for anywhere that I'm having too much of temperature, especially as I said, around the engine, under hood. And then blue is for anywhere like this one that I'm having the voltage in that area to be maximum 42. Maximum 42. Like in anywhere that I'm having, this one is the black in here is, I'm going to clean up this one. The black is for closer to like the engine or high temperature. And then the blue is for maximum 42. Like, for example, all of those wires coming from a string wheel, which is maximum 42. And then I'm having orange. This one is less used inside the car because this one is also for high voltage, but even higher than this one. This one is more focused on temperature, but this one is more focused on the voltage. Voltage for this one maximum, this one can tolerate maximum up to 650 volts. Therefore, anywhere that we have such a possibility to have something between 144 to 650, we must use the orange one. Make sense? Any questions so far? Clear? So I'm going to finish it up right in this slide, which is talking about, again, wire size and then the terminals. Because remember I said, in addition to the wire, in addition to any protection, such as fuse, such as, what else did we discuss? Fusible link, regular fuse, breakers, they do have different type. Still, we have another component which is important, which is the terminal. Terminal also is a factor of the gauge of the wire because they are coming with different size, different color, both of them, right? Size and color. Also, color may not really be important in any electrical component. But still, if we follow the colors based on the standard, troubleshooting for the technician or the next user is becoming much, much easier. Look at here, this is a schematic of wiring. A schematic of wiring is a bit different than a schematic of electrical system. Remember I said engineers in automotive industry focus on wire harness design because this is extensive knowledge that they need to be aware of it. They have to be trained with all of this schematics drawing as well and reading. Reading a schematic by itself is a really great skill to learn. So for example, in here, whatever information, especially if you are someone who's working on the CAD design side of it, and you're supposed to design the wiring harness inside the CAD, then send it for prototyping. If you have wrong information being added to the CAD, therefore the prototype is not going to be accurate enough. So that's why the engineer responsible for such a design must be aware of what does it mean if inside the CAD design or 3D design. Most of the time for the wire, we do not focus on 3D design, right? Because we don't care about the dimension. We care most about the length, the thickness, and this stuff, which can simply be addressed like what I have right in here. For example, 0.8 in here means the wire size. Let me do it one by one. This is important. Pay attention to learn it. 0.8 is the wire size. PPL is the color, wire color, right? Means purple is the color. What should be the color for this wire in case you are a technician following the schematic to go troubleshoot that system? So you just hold the schematic and then you follow and see if inside like the vehicle anything is damaged and you're supposed to repair it and replace it in some like maybe some events. Then you know, okay, I have to just look at this purple. It has to go to, for example, this is the direction. This is the direction of the flow of current. This is important. And then, like for example, in here, if you have PPL/white, means the wire color is a combination of the purple and white. I'm sure everybody's seen those kind of wire that they do have like a strip of different color on them. So it's a solid color, but there is then a strip of a different opposite color. For example, here, again, the size is still 8, but also in here is just a solid, only purple. Here is combination of white and purple, right? So next, this one is like shown right in here. This is your breaker. Like, for example, if you have a light, you may have a breaker, but then you have like some, I would say, load or something like that. And then this one, for example, another color, BLK stand for the black. This stand for the size. And then 20. 20 is important. 20 is the circuit number. Why is that? Because I'm having tons of circuits being designed inside that only electrical schematic wiring harness. Therefore, you have to be able to understand this wire is supposed to go connect to which circuit, because lots of electrical schematic are there, right? So the circuit number, this is the wire for circuit number 21 and so on. So each of this means something. Now let's look at the terminal. This is the electrical symbol of terminal in electrical schematic or schematic drawing for wire harness. If you see something like this, do not get confused. This is not motor. Sometimes a student may think, oh, this is a motor. No, this is like a circuit, like in here, yeah. So, and these are your terminals. Terminal could be different size, different color. And I believe I've already included at some point some of the, let me see. I've included some of them. No, just this one. I don't have the picture of this, just this one. So you have like, even you may have green. You have green, red, you have yellow, and most of the time they may come with different color, but if you look at here, you can see The shape might be even different based on the application where they are going, or even in this direction, you can see they might have feminine, masculine, they might have like female, male. So like the terminal is important. You want a female or male, even these two, if you compare them, you can understand female, male, like the application is the same or the performance is the same, but based on where you are connecting it, the shape may change. So I'm gonna close today's lecture right in here, but still anyone who has any question, feel free to ask. Any question for me?